Good morning friends. My name is Rituraj and today we are going to continue our lecture series of the chapter DC circuits. So in this lecture we are going to discuss about the topic Thevenin's theorem. Okay, so let us first write a statement of Thevenin's theorem. According to this theorem, any two terminals in a network however complex can be replaced by a single source of EMF source of EMF with series with RH as a series resistance. Okay, so this statement is very important in respect of university exams. So now further I will write the steps to solve any question by Thevenin's theorem. Please note this down. Okay. Now I will just rub all this. Okay. Steps. First, step 1 is to remove the branch resistances through which the current is to be calculated. Second step, calculate the voltage across the open circuited terminals by using network simplification techniques. step is to calculate RTH, which is the effective resistance across the both branches, excluding the resistance through which current is to be calculated. Please note this, I will rub this within 5 seconds, write further points. 1, 2, 3, 4 and 5. Fourth step, to draw Thevenin's diagram. So now what is Thevenin's diagram? So Thevenin's diagram is a diagram which contains the branch and the resistance through which the current is to be calculated, and it is in series with a voltage source, that is VTH, and in series with RTH, that is the effective resistance of rest of the circuit. So showing this diagram in any question while solving is very important. It contains marks. So this is our Thevenin's diagram. So this is the part which is consists of complex circuit, and this only complex circuit we reduced it into a VTH and RTH. So this is a very important step while solving the question. And step 5 is to use the formula, that is IL is equal to VTH upon RL plus RTH, where IL is the branch current, RL is branch resistance. Okay, so this is the final formula through which we calculate the answer which we want. So please note this down. 1, 2, 3, 4 and 5. So now let us solve a sum based on this theorem. Okay. So I'll write here question. I will draw a diagram first. Okay, so now this is our question diagram, and question is to find current through 5 ohm resistance is how much. Okay, so as we have decided, we need to solve this sum with Thevenin's theorem. We could also solve this sum using using any nodal analysis or mesh current analysis or superposition theorem also, but we will solve this question with Thevenin's theorem. You can check this question with all the other methods also. So now question is through 5 ohm resistance. So this is the branch through which we need to calculate current. Let's name that branch A, B. Okay. So as we had discussed in step 1, we need to stop or short that branch through which the current is to be calculated. So let's move on to the question. I will rub this to draw a step 1 diagram. So as you can see, I just rubbed that 5 ohm resistance branch and just wrote there VTH, if you can see. So in step 1 we need to find VTH. So I will solve it. Now how we will find that? First we need to find current through this mesh and this mesh. Let this mesh be mesh 1 and this be mesh 2. I will name the current in a clockwise direction as I1 and current in this branch as I2. Okay, so coming back to the question, in step 1 we need to find VTH. Okay, I will write here. Okay, so apply KVL in mesh 1. So I will just apply the KVL. Please revise and solve with me. Okay, so the final equation is minus 7 times I1 plus I2, which is equals to minus 10. So this is my equation number 1. Apply KVL in mesh 2. Okay, so this is my mesh 2. I will apply KVL minus, I just made a mistake, minus 1 times I2 minus I1 minus 2 times I2 minus 3 times I2 is equal to 0. So this equation turns out to be I1 minus 6 times I2 is equal to 0. This is my equation number 2. Please note this down. Okay. So now let us solve these both equations with the help of our scientific calculator. Okay. Minus 7 enter, 1 enter, minus 10 enter, 1 enter, minus 6 enter, 0 enter. Okay. So our answer turns out to be I1 is 1.46 ampere flowing in clockwise direction, and my I2 is great 0.24 ampere flowing in this direction. Okay, so now coming back to the question, we need to find VTH. So now we will apply this KVL in this branch from A to B. So let us consider our direction of motion as we are moving from this point to this point, then we are passing through 3 ohm, then 20 volts, and then again to B point. So let us apply. This is the most crucial step in this theorem. Okay, I will write it. Please note it side by side. So VA, this is our start terminal. VA minus our I2 is in this direction, which is in direction with our flow, so it will have a negative sign, 3 times I2, and this 20 volt EMF is opposing our direction, so it will also have a minus 20 sign, and this is our end terminal, which has a voltage of minus VB. So we will simplify this. I will write VA minus VB is equal to 3 times I2 minus 20. So now what is VA minus VB? So it is nothing but VAB, which is nothing but our Thevenin's voltage, that is VTH, and which is equal to 3 times, what is the value of I2? 0.24 minus 20. So I will just solve it. 3 into 0.24 minus 20. Okay, so its answer, it turns out to be minus 19.28. This is my VTH. Don't worry about that negative sign. Further we will discuss why there is a negative sign. So currently let's move on. I will just write this answer here on the top for the reference. That is VTH is minus 19.28. Okay, so please note all this down. I will going to rub this, and then we will move on for our step 2 to calculate RTH, that is the effective resistance of the open circuit. Okay, I am going to rub this now. Right here, step 2. Just a minute. Okay, I had paused the video. I was just refilling my pen. So I will just write again. Step 2. Calculating TH. Okay, so I will draw a diagram in which we will replace all the sources with their internal resistance. Okay, you remember what is internal resistance? We had discussed it in one of our lecture. Okay, so what was my diagram? It was like this. Then here was the resistance. There was the resistance here also. Here. What was the magnitudes? This was my 3 ohm, 2 ohm, 1 ohm, and this was my 6 ohm. Correct? Okay, so now let us solve this. We will write here R effective is 6, which is in parallel with 1. This entire thing is in series with 2 ohm resistance, and this entire thing is again parallel with 3 ohm. Okay, so let us solve the first this branch. I will write it 6 into 1 whole divided by 6 plus 1 whole added with 2, and this entire thing is in parallel with 3. So my this turns out to be, I will just need work LC, 6 divided by 7, that's 20, so it turns out to be 20.85, which is in parallel with 3 ohm resistance. Now this answer I will just calculate it. We can write this as 20.85 into 3 whole divided by 20.85 plus 3. Okay, so now my answer turns out to be 2.62 ohm, which is nothing but my RTH. Okay, so correct. Now I will just write this value again on the top so that I can refer it. RTH is 2 point how much? 62 ohm. Okay, so please note this down. I will rub this and we will move on for our step 3. Step 3, drawing Thevenin's diagram. Okay, I will draw it here so that we can use that diagram for further reference. So this is our diagram. This was my A terminal, this is my B terminal, this was RL having load resistance of 5 ohm, this is my calculated RTH, and this was my VTH. So by convention we will write IL in this direction, but as we have seen, VTH is having a negative direction, so drawing VTH like this won't make any sense. So we will convert this diagram into our final diagram, which will be like this. This EMF source will get reversed. I will write it with now magnitude also. 5 ohm. This is my 2.62 ohm. This was my 19.28. Now why I didn't wrote a minus sign here? The reason was that I just flipped the direction of our EMF source. This was again my A and this was again my B. So and this was our conventionally taken IL. So now let's use our formula, that it will be now our step 4. The formula is IL is equal to VTH whole divided by RL plus RTH, which turns out to be minus 19.28 whole divided by 2.62 plus 5. Now my answer is, I will calculate it, 19.38. This answer turns out to be minus 2.65. Now 5 ohm is minus of that of IL, which is 2.65 ampere flowing in anti-clockwise direction. This direction needs to be shown. So this is our final answer. Okay friends, please note this down. Okay, so I had previously also solved this question in my notebook, and the answer was too close to this answer, that is 2.5. We have got 2.65, so it won't make any difference in university exams. So please note this. Now I will give you one more question as your homework question. Okay, I will rub this. Finding a question for you. Just give me a few seconds. Okay, I got one of the question. So there is a circuit diagram. This. So my question is to find current through 5 ohm resistance. So I will give you a hint, that is, this is my A point and this is my B point. So you must solve this question with Thevenin's theorem. I will just explain you in small words that with first step you will going to short this branch and calculate VAB, that is nothing but VTH across that branch. Then you will calculate the effective resistance of the remaining circuit except this 5 ohm resistance, and then you will use our Thevenin's formula to calculate the final answer. And please mention the direction of our final answer, that's more important. And with that, also draw our Thevenin's diagram, because that's also very important, it has a marks. Okay, so I will just give you the final answer also. So its answer turns out to be 0.321 ampere flowing in this direction. Okay. Okay. So this is our beautiful question, and I request you all to solve this question. If there seems to be any mistake in this answer, then you can also solve this question with our mesh analysis, nodal analysis, or superposition theorem. Okay, so practice it, and don't forget to like, share, and subscribe this amazing channel. Thank you.